Welcome to Web Handling. My name is Dave Roysum. I am super excited to continue this new series on troubleshooting runnability. Please see the two previous clips on how to get started and measurement. In this clip, we will take a deep dive into prediction, as well as theory, for these statistically rare events. In the previous clip, we showed continuous strength measurements. Strength on a particular section of the web as a function of MD position in that web. Please review that clip and see my paper on runnability for a deeper dive into the details. In any case, there are some robotic testers that can do things like that, as well as two specially designed pilot rewinding machines. Perhaps the most interesting of all was the progressive draw tester designed by the Institute of Paper Chemistry, which was in my backyard, Appleton, Wisconsin. The unwind sets a moderately high starting tension, and each of the half-dozen geared draw sections increases that a tiny bit more. Depending on which section the paper breaks in, you know how strong the web is. Both of these rewinders are ways to do accelerated testing. Instead of running normal tensions and needing to wait for many rolls to find your first break, we run much higher tensions and get many breaks per roll. Thus, breaks are conveniently frequent for testing. Not too many, not too few. However, the challenge is not just measurement. We just showed you at least two ways this can be done. The challenge is also that we need a physical model or empirical curve that allows us to predict performance at modest running conditions from data obtained at much higher tensions than you would normally run in practice. As it turns out, for paper anyway, the log of the distance between breaks versus web tension is pretty close to linear, as far as we can tell. Even if you don't go to this kind of predictive effort, you have one very important takeaway. That is, web breaks vary with the second or third power of tension. In other words, tension is a very big knob. However, this is not just average tension. It is also sources of tension variation, such as we described in the previous clip. The diagram here is the result of hundreds of such studies done at my lab at Beloit-Rockden's Research Center. Shown here is four extremes of combinations of strength and variation taken from those hundreds of studies. Unfortunately, this may be more qualitative than quantitative because real-world runnabilities may vary only 2 orders of magnitude, while these results predict larger runnability variations. Still, we can see the effects of both average strength and strength variation. They are about equally important. This has testing implications because while averages may be recorded, variation seldom is. Brittle web breaks are dominated by fracture. The tensile fracture mode 1 is what the web experiences most of the time in your machine. In contrast, most lab tests, such as the Elmendorf tear, measures mode 3. As a consequence, fracture provides us a super useful concept but perhaps not so much a predictive utility. In the next slide, we will show why fracture helps us understand key attributes of web breaks. It is well known that about 80% of all web breaks begin at an edge. Why? It is because that, all else being equal, you can take only half the size of a flaw on or very near the edge as you can elsewhere. The figure here shows the overall strength as a function of two things, flaw size and flaw orientation. Also coming from fracture mechanics is the radius of curvature of the flaw. A crack is super risky, while a hole of equal size, not nearly so much. Let me close with one last concept I hinted at earlier. That is, which lab test you use matters. It matters a lot. This is above and beyond the sample size and variation issues we already discussed. Recall in the previous slide, we showed that Mode 3 tear measurements are quite different than Mode 1 web breaks in your machine. Thus, none of the researchers have found a connection between tear and runnability, at least so far. While common sense and common testing practice might indicate that MD strip tensile strength might be a good candidate runnability measurement, this is simply not the case, at least most of the time. I say this because of all the researchers studying these problems, only a couple of authors have ever found a statistical connection between ultimate MD strip tensile strength and runnability in your machine. What has been slightly more predictive is TEA, which is short for total energy absorption. Mechanics people sometimes call this modulus of rupture. It is one measure of ductility. If you review the first clip in this series, or read Page and Seth's work, you will note that the winter season is big troubles for web breaks. Those of you who are familiar with paper as a material will know that the tensile strength increases with dryness. So, why then is the drier winter paper break more often when it is in fact stronger, at least by the MD tensile strength test? Simple, because dry paper is brittle rather than ductile. In short, the TEA, modulus of rupture, and ductility all have been decreased during the dry months, completely obliterating any benefits of a stronger tensile. In summary, we now know that some measures of ductility may be more predictive than other tests. However, beware of small sample sizes such as those from the test lab. Also, beware that variability of load and strength often dominate real-world runnabilities. There will be those who did not take my advice early on in this series about not volunteering or raising your hand for these kind of problems. For those people, as well as those who got their hand raised by their boss or customer, I give you some additional information. First, start with these 3 clips, and then move on to my runnability articles in the Tabby Journal. There you will find a summary of the state of the art and science, some original work, and a very complete bibliography. For those of you who want to go even further, the next step would be to go to the free Roysum library by Abbott Apps. Type Runnability into the search box and you will find more than 100 articles on the subject. Indeed, starting with my Web 101 School for Essential Concepts, and then turning to my Web 201 YouTube clips for supplementary information, and finally the Roysum Library search engine for advanced research is a great path for most web handling issues. Thank you so very much for allowing me to share some of the challenges and solutions to working with rare defects such as runnability or web breaks. Stay tuned to this all-web handling channel for even more practical troubleshooting clips. Please like and share if you found something interesting or useful. See you next time.